This presentation is about reliable energy efficient multi-hub leash-based clustering protocol for wireless sensor networks. I am Mahdi Jafar Rangchi and my colleague Somayeh Abniki. With same contribution, we have worked on clustering protocols for wireless sensor networks, and at the end, both of us tried to propose a Markov chain for modeling uh, the leach protocol to some extent. Okay, let's start with an introduction to the WSN. WSN is composed of some sensor nodes which are low in consumption of power energy. They are utilized with battery, and also they are very small size with limited power and computational capacity. But also they are also very cost effective, ready to be used in massive numbers. About their capability, they are capable of sensing and computing, and also send the sensed data and computed data to a destination via wireless communications. Our goal in implementing wireless sensor network is to monitor an area. The phenomenon under monitor can be temperature, light, motion, pressure, and etc. And about the location, these sensors, because they are very tiny and they can be spread from airplanes or helicopters, they can be spread on hard to access environments. So, for example, in mountains or forests or areas that are unreachable by a human. Some of their application is in military, medicine, traffic control, monitoring, agriculture, video surveillance, and every place that we need to send some data and send the sensed data to a location, and specifically in wireless sensor network, this destination is named base station. About the technical issues we have here, because of the limited size and processing capability of the sensors, we need to consider an optimization into the computation algorithms. Also, in contrast to conventional or traditional networks, here we cannot use the same network discovery protocols because they use massive energy. And next comes power management. Here, the problem is to prolong the network lifetime. So many energy management methods have been produced. For example, for the nodes that they can harvest energy harvesting algorithms has been developed, or data gathering has been modified. The algorithms of data gathering has been modified to consider energy consumption. And all the terms that you see here are different aspects of energy management methods that all can be reconsidered and thought about considering the energy consumption. One of the methods that we are focusing in our project is clustering and multi-hub routing. It tries to give some routing protocols specifically for wireless sensor networks considering energy consumption. Again, talking about the technical issues, because these sensor nodes are left unattended, security of the gathered data is under question, how data is routed and how the sensors are controlled, how nodes collaborate with each other to process data and communicate with each other, and are the sensor management centralized or distributed, and what we are going to do in each sensor because of limited computational capacity is again under question. Speaking about the clustering approach, which we are focusing in this project, by using clustering approach, we try to avoid long distance communications, and by incorporating a hierarchical structure, every node tries to send the sensed data to a near destination, and by repeating the same structure, we wanna to reach a better scalability. And because the sense data temporally and spatially are highly correlated, we can have high compression and aggregation in sense data. So at the end, we are trying to prolong network lifetime and monitor the area under coverage for a longer time. The network becomes partitioned into some clusters. Each cluster has a cluster head, and sensors near the cluster head gather data and send it to the cluster head. The cluster head periodically aggregates the data and in one signal sends to base station. One of the most famous clustering algorithms here, and one of the first algorithms, is named the LEACH. LEACH algorithm tries to divide the network in some optimum number of clusters. Each cluster has a CH and some simple member nodes, and member nodes send the sense data based on some rounds to the CH node, and CH node, after aggregation, sends the aggregated data to the base station. Every round is split into setup phase and a steady phase. In the setup phase, CHs are elected and the joining requests are sent to CHs, and the clusters are formed. And here you can see a threshold which defines if a node should become a CH in the current round or not. This formula is a random number. Each node produces a random number between 0 and 1, and if the number is less than this threshold, the node becomes a CH in the current node. And after passing the setup phase and clusters are formed, the steady state phase starts, which CH sends a TDMA schedule to all the members, and every node based on its specific time slot sends the data to the CH, and at the end CH aggregates data and sends to base station. Its pros are distributed and energy efficiency without any global knowledge, and its cons are limited scalability and limited multi-hopping. Some other clustering algorithms trying to improve leach are TL leach by having a secondary CH in the same cluster, and after a threshold, the first CH's energy reaches to a minimum threshold, the second CH comes into the party. Next one is LEACH-R, which tries to improve the threshold by incorporating the residual energy of the CH. And we can say still problems here exist, like optimal cluster size, what is the number of optimal cluster heads, how many levels of hierarchy are needed, and distributed or centralized algorithms.
One of the enhanced algorithms that improved leach is multi-hop leach. This algorithm is different from leach in 3 criteria. There are new rules for CH selection, and also there are new type of computing runtime, the amount of runtime, and the most important one is that there is a multi-hop communication, a hierarchy for CHs to send aggregated data to each other and transfers this data to base station. And the first round of this algorithm is similar to leach, but the following rounds, in the following rounds, there is a new criteria, energy, ratio of energy that is calculated by dividing remaining energy to initial energy to has an effective impact on the chance of a node to be selected as a CH. And There are another equation for calculating round lengths that again has energy rate as an input and calculates the round lengths based on this energy rate and initial round lengths. And the idea is that round time is not fixed in this algorithm, and it's variable, depends on the remaining energy of a round and of a node. And at the first, the round time is fixed to 150% of the leach, but it decreases to 50% of the leach algorithm. What we propose in our study is two different Markov chains based on the decreasing energy or level of energy of each node in a cluster. There are two different nodes in cluster, simple nodes and CHs, as my colleague described. That in a TDMA slot, each simple node tries to send the sense data to CH based on the schedule that CH shares at the first of the TDMA slot. And the last time slot or mini time slot, CH aggregates this sense data and sends it to base station. For simple nodes, we propose this Markov chain that has three different states. Each simple node is in a sleep state if this mini time slot is not specified to that. And so when the time slot, when it reaches to the time slot that it belongs to, starts to send the sense data to CH with this probability. Chi is the number of simple nodes in the cluster, and one node is CH. And after transmitting, again, nodes goes to a sleep state. This is repeated in every TDMA time slot until the remaining energy of node is going to less than a threshold, and it goes to dead state. For CH, there is three different states. Each CH starts to receive the sense data from simple nodes in mini time slots, and at the last time slots, it aggregates the data and sends it to base station, and again goes to receiving data for the next TDMA slot. And with the probability of going a CH to dead state is dependent on the remaining energy that the node as a CH has. And if this energy is less than a threshold, it goes to dead state. And the whole system goes to another setup phase for selecting a new CH to substitute with the dead CH. What we proposed in this study was two Markov chain for every TDMA slot in leach algorithm. We assumed some things for this study. We assumed that there is always a packet ready in simple nodes to be sent to CH. And if a node goes to sleep mode, if a simple node goes to a sleep mode, the amount of energy consumption is negligible. And at the end of the TDMA time slot, CH aggregates the sensed data, the received data, and sends it to base station.